10c, but we'll probably need to do all of 10 before we land at c. Ooh, I see product rule. 2 product rules right off the bat there. Consider the curve given by that ugly thing. Find dy dx. So I'm going to assume you were okay with part A, but I probably can't do C without part A. So I'm going to product rule on the fly here. And I've mentioned doing that before. I don't know that I've done it before. But some of you will get to the point where you can pull this off. If you need to write out everything, write out everything. But if you can label them and then kind of go from there, then that's okay too. So first times derivative of the second. So that would be x times 2y dy dx. First times derivative of the second. Plus the other way around. Second times derivative of the first. Well, that's just 1. And then same thing, I mean not exactly the same thing, but same product rule here for the second chunk of stuff. I'm going to put the minus sign out front rather than assigning it to f or to g. I think that's easier, and I'll just handle it later. So everybody's going to get the minus sign, but I don't want to mess up my product rule. I want to do the product rule without the minus sign, and then I'll handle the minus sign. So fg prime, first times derivative of the second, plus second times derivative of the first, 3x squared. And again, if you kind of go overboard with the derivatives, and you think, oh, that's dx dx, you're not wrong. But dx dx would just be 1. So it's almost better to make that mistake than to forget about it. Because if you remember it and go overboard, then you'll see dx dx and be like, oh, that's 1, no big deal. If you forget about it, then you're going to miss the problem. Equals 0. All right, so a little bit of cleanup work here. 2xy dy dx plus y squared minus x cubed dy dx, minus, because that minus sign goes to both of them, 3x squared y equals 0. Still on part A, just trying to get dy dx. Our calculus work is over. Now we get to do some algebra. So I'm going to move over. See how few steps I can do this in and not get lost. Either lose you or lose me. I'm going to move those 2 pieces over. So 3x squared y minus y squared. And then I'm going to factor out dy dx from what's left. 2xy minus x cubed. I guess if you were really ambitious, you could have skipped even one more step, but are we okay up to there? Move the non-dy dx stuff over, factor out dy dx from what's left, and then dy dx equals, we're just going to divide by all of that. So there's my dy dx. I suppose somebody might want to factor out a y from the top and an x from the bottom, but don't do that yet anyway. Part B, find all points on the curve whose x-coordinate is 1 and write an equation for the tangent line at those points. So you didn't ask for that one, so I'm going to pass on that one, but I would plug in 1 to the original. And it looks like I'll get 2 values of y. Maybe I factor that. That gives me 2 points. 3 and 2, one's positive, one's negative. And then we'll plug those in to find the slope. So I don't think B is too hard. Let's do C. Find the x-coordinate of each point on the curve where the tangent line is vertical. Tangent line is vertical. Vertical, that means up and down. Tangent line, that means derivative at a point, or slope at a point. trying to piece together what I know to come up with something. Oh, what's the slope? Derivative means slope. What's the slope of a vertical line? Undefined. That's up and down. It doesn't have a slope. Again, it doesn't mean our problem's over. It just means that the slope is undefined. The only way we get an undefined slope is if 0 is in the denominator. So I'm going to take the denominator of my derivative and set it equal to 0. Because if that denominator is 0, then my slope is undefined. And if my slope is undefined, then I've got a vertical tangent line. Well, this doesn't look promising, except that I could factor out an x. And so I set the pieces equal to 0. So there's a good one, x equals 0. That other one, I don't know what's going on there. I'm not going to mess with that. But there's my easy answer, x equals 0. Now let's make sure I answer the right question. Find the x-coordinate of each point on the curve where the tangent line is vertical. Well, that's it. X is 0, the x-coordinate. So we'll go with that. And the x-coordinate. Yeah, so we're good.
You don't do anything with the other one?
So to do something with the other one, 2y equals x squared. I guess I would have to do something with the other one. Y equals x squared over 2. And then to find that, I'd have to plug it back into the original. Probably didn't do this before. So I'm looking back at the original equation, and in place of y is going x squared over 2. So this is going to be x to the 5th over 4 minus x to the 5th over 2 equals 6. Fourth minus a half. Or I could just multiply through by 4 and be done with that, the fractions. Let's do that. So x to the 4th minus 2x to the 5th equals 24. Wait a minute. Whoops. X to the 5th. So that means negative x to the 5th equals 24. So the 5th root of negative 24. Yep, so there's the other answer. Yuck, but needed to do it. That's an ugly one.
Why did you take the denominator instead of the
Okay. Because for a tangent line to be vertical, that means the slope is undefined. But a slope is undefined when the denominator is 0. Right? Back to the old Algebra 1, okay, no stuff, if they taught it that way. Right? 0 in the top is good, 0 in the bottom is no. In algebra, usually just said, oh, can't do anything, it's no. And now we're like, well, it is no, but more importantly, it's undefined, which means it has a vertical tangent line. All right, that was a long one, but that had a lot of stuff in it. It had implicit, had 2 product rules, had algebra, had slope, undefined slope, vertical lines, lots more algebra. So a lot of stuff going on there. So let's move on to the lesson.